What's up, people? This is Mr. Reboff. We are on toolkit number 21, operations with rational expressions. And you see what we're doing here, right? You can look at it. What is operations? It's adding ugly fractions, right? These are hideous. Okay, so we're going to teach you how to do that, a couple tricks. Um, and there we go. All right, so let's jump in. Let's go with addition and subtraction first. In order to add or subtract, think about this back in the day. If you had 1/2 plus 1/4, what would you need to do? We need a common denominator, right? We would need to get a common denominator. So 2 and 4, and you're like, hey, all I have to do is multiply this by 2, and then they'd both be 4. So you'd be like times 2. And if you do it to the bottom, you have to do it to the top. And once you do that, you'd have 2/4 plus 1/4. And then you add the tops because it's adding. If it was subtracting, you'd subtract the tops. We're going to add the tops here, and we're going to keep the bottoms the same. Okay, same idea here, except way uglier. Okay, so step number one is factor everything. Factor anything that you can possibly factor. Okay, obviously, this is factorable. Nothing else here is really factorable. If I look over here, I can factor out something from both of these. I can factor out a 4, right? Even though it's not factoring like this, right? Or like this will be. Okay, I can still factor out a 4. So factor everything that you possibly can, even if it's just a number from both terms. Okie dokie. So let's factor this one right here. Okay, so that's factorable. I'm going to grab my handy dandy little pink sheet here. You could do this on the side, right? You could be like, okay, multiplies to be 2, adds up to 3. So multiply adds. That's got to be 1 and 2. 1 times 2 is 2. 1 plus 2 is 3. So this has to be x plus 1, x plus 2. Now, normally, because I'm a nice teacher, this here will end up being one of these two. Okay, so we don't have too much work to do. I try to be kind of nice. So we can see that x plus 1 will be one of the two factors here. That makes it a lot easier. So x minus 2 over x plus 1, x plus 2. And then we're going to add 2 over x plus 1. Okay, so there's first step done. I factored this. Got it. We got it. There we go. Factor anything that you can. That's our goal. All right, once we do that, I think just kind of like here, how do I get these to be the same on the bottom? Okay. I always think of like myself when my brother got something that I did, and I'd be like, Mom, it's not fair. My brother gets big and I don't have it. Right. So right now, this is me, and I'm looking at my brother. And what does my brother have that I don't have? An x plus 2 on the bottom. I want that x plus 2. I've got the x plus 1, but I want the x plus 2. So what I'm going to do, Mr. Reboff, is I am going to multiply top and bottom by x plus 2. So if I do x plus 2 here, I'm doing a different color to show that that's the next step. So x plus 2, I'm going to multiply that top and bottom. So now check it out. Bottoms are the same. I'm going to be able to add the tops together. All right, so let's go x minus 2 over x plus 1, x plus 2, and then plus, and I'm going to distribute this through. Why not? 2x plus 4 over that same bottom, x plus 1, x plus 2, right? And now I get to add them together. So x minus 2. If this is subtraction, like we'll see here, we have to subtract the first and the second one. This is addition, so we just add, so that makes it easy. 2x plus 4 all over this bottom. I'm going to write the word blob for a second. I know that this is the bottom, okay? I'm going to write blob just to hold space. X plus 2x is 3x. Minus 2 plus 4 is plus 2. And since I'm at the end now, I'm going to write x plus 1, x plus 2. I'm going to replace the blob with what it actually is. Okay, so this is a lazy way. If you don't want to keep writing the same denominator, once you get to that denominator, if you want to write blob in my class, you can write blob here and blob here and blob here. And then once you get to the answer, go ahead and write it in. It's just like, you know what you're going to do, right? All right, here we go. Next one, subtraction. This has a couple little crazy things that make it a little more challenging. All right, so same thing. We're going to factor everything. I can factor this right here. Okay, I already talked about that. I can take out a 4. So it's going to be 3 over 4 times x minus 1. And then minus, nothing I can do there, x plus 1 over, and then this is a special factoring. Do you remember it? It's difference of squares, difference of perfect squares. And this is my little hint. X minus 1 is going to be one of them. X minus 1, and then what's the other one? X plus 1. Right? Again, if you're scared, I would encourage you to multiply it out and make sure it works, right? X squared plus x minus x, the x's cancel out. So we have x squared and then minus 1, that becomes that. Now, notice a couple cool things happen, right? Once I did that, I see that these two cancel out. Ooh, now they don't really cancel, they divide, right? So this divided by this is what? Anything divided by itself is 1. Okay, so I'm going to cancel these out, and this becomes a 1 on top. So let's rewrite it. 3 over 4 times x minus 1 minus 1 over x minus 1. And I'm not going to blob it yet because these are not the same bottoms, but man, this is a lot easier problem now, isn't it? All right. So again, you're looking over at your sibling, and what do you want that you don't have? Yeah, you don't have that 4. So let's multiply a 4 on the bottom and the top. All right, so let's do that. 3 over 4 times x minus 1 minus 4 over 4 times x minus 1. Notice I'm not distributing these out. I'm just going to leave them like that, right? Same thing as over here. I didn't distribute or FOIL that out. I just left it like that. It's going to be important when we graph these later on. Okay, just leave it factor. So much easier. All right, so now this is not bad because I just have the minus here. If this was 4 minus x, I'd have to, again, remember to minus this and minus this. We have to kind of distribute that minus sign. But here we just got 3 minus 4 on the top over, I'm going to write blob, and that equals 3 minus 4 is negative 1 over 4 times x minus 1. Okay? All my blob is it's just this, right? So don't get freaked out. You don't have to say blob. You can just keep that, right? I just do it because I'm lazy, and writing blob is a lot faster than that. Okay, good. All right, here we go. Moving on. Multiplication, division, way easier. Way, way easier. Division has one little special trick. But again, step number 1 is factor everything. Everything, right? This you can factor, this you can factor, and this we can factor. This we can't. That's as far as it can go. So let's start with the factoring. So we got x minus 2, can't do anything about that. And let's factor this. We've already done this one, right? It was up here. It's x plus 1, x plus 2. So I'm just going to steal that. X plus 1, x plus 2. Can I cancel these two out? Nope, not exactly the same. All right, and this is times x squared plus 2x plus 1. Okay, I can, again, grab this, and it's going to add up to 2, and it's going to multiply to be 1. So that's got to be 1 plus 1, right? 1 plus 1 is 2. 1 times 1 is 1. So x plus 1, x plus 1. All over, and here I can factor out a 4, kind of like I did here, right? I factored out a 4, and it became x minus 1, right? So here I can factor out a 4, and it's actually x minus 2. Okay. Okay. And now here's the rule. If it's all multiplication, we can cancel, which means divide, anything that is top to bottom. Okay? So if it's all multiplication like we have here, right, we can cancel anything top to bottom. So I see an x minus 2 on the top. I see an x minus 2 on the bottom. Those can cancel. I see an x plus 1 here. I see an x plus 1 here. I can cancel top to bottom. And is there anything else I can cancel? Is there an x plus 2 in the top somewhere? Nope. Is there an x plus 1 in the bottom somewhere? Not anymore. I already used one. Is there 4 up here? Nope. So we're done. What's left over after all that destruction? We've got x plus 1 on the top. We got 4 times x plus 2 on the bottom. And that's it. That's all I can do. Not bad, right? That's actually, once you get through the factoring, Multiplication is kind of fun because you just get a, right? Cancel a whole bunch of stuff out. And it usually does cancel. If you're doing this and nothing cancels, you better check your factoring. That's where most of the problems happen. Okie dokies. Division. Division is a little tricky. Okay, my trick to you, and you might remember this, is KCF, which stands for keep, change, flip. So if you're dividing fractions, we keep, change, flip. You may have remembered this before. 1/2 divided by 3/7 turns into keep, change, flip, right? KCF. Keep, change, flip. We're going to do the same thing for this. And I'm just going to do it first. Get rid of that nasty, nasty division sign. Turn this into multiplication. So we keep the first one. I'm going to factor this while I go. 2 times x minus 5 and change to a multiplication sign and then flip 4 over. And I'm going to factor this at the same time. X squared minus 9 is another difference of perfect squares. That's going to be x plus 3, x minus 3. Cool. Cool. All right. Now that I've got this, I've factored everything, right? I've keep changed flipped, and now things are going to cancel out. I see an x plus 3 here and an x plus 3 here. Those are going to cancel out. I see a 4 on top and a 2 on the bottom. They mostly cancel, except there's a 2 left over on the top, and I can't do anything about these two. So it's going to be 2 over x minus 5 times x minus 3. And that's it. Cool, cool. All right. So one last trick that you're going to see. This is the flippy trick. I'm going to show you what happens here. Right. We've got 1 minus x. If I factor this bottom, I'm going to get x minus 1 times x minus 1. Okay. You could check me on that, but it's true. Okay. Can these two cancel? No, but yes. Okay, there's a trick. It's called the flippy trick. Okay, if I want this to flip around, if I want this to be x minus 1 instead of 1 minus x, the flippy trick is to multiply by -1 twice. Okay, watch. Are you ready for it? If I multiply something by -1 twice, does it come back to where it used to be? Think of a number, multiply by -1. Multiply by -1 again. You come back to the same number, right? 5 becomes -5, becomes 5 again. You come back to it if you multiply by -1 twice. So this is legal, right? This is legal to do. It's usually like useless because why would you do that? But here's why you might do that. So I'm going to take this 1 minus x and I'm going to multiply it by -1 2 times. Okay? X minus 1. X minus 1. Okay, let's distribute this. But we'll keep this one. Okay, so what would I get? I would get -1 plus x, right? And then I'd still have a -1 out here. I'm not going to multiply that one through. Okay, even though it's there, I technically multiplied the top by -1 twice, but I've only done one distributing so far, and that's okay. X minus 1. X minus 1. All right, what do we notice about this? Can I switch these two's position? I can, and if I do, this equals x minus 1. So what I have now is, I'm kind of running out of room here. Let's go over here. I have x minus 1 times -1 over x minus 1 times x minus 1. And now I can cancel these two. So I have -1 over x minus 1. So I was able to simplify. So if you're so close to simplifying, if you just flip two things around, you can use the flippy trick. Okay? It only works really when it's something minus x or something minus 2x or something like that, right? We need a minus sign in between for us to do it. And that's that. Number 21 is done. Good job, people.